everyone, and welcome to TLDR for weeks 6 and 7. We are going to be working with firewalls next, and I've given this 2 weeks because firewalls can actually get very complicated, and I want to make sure that everybody has enough time. The learning outcomes for these 2 weeks is going to be working on how to use SSH easily, add and subtract firewall rules and manage your IP tables, and start working on setting up restrictions either by port, IP, or app, and setting up some emergency settings. Firewalls is what's considered a first line of defense for your computer. A firewall examines the packets that are coming in and out of your network, and basically what you end up doing is figuring out if you want to let the packet in, deny the packet, or send the packet somewhere else. We can do this by looking at, say, IP addresses, always allowing packets from some IP addresses or always forbidding them. We can do it by looking at MAC addresses, or we can do it by looking at the port that the packet is going to be using or the application that the packet is for. You can do a deep packet analysis for data. However, the more deep packet analysis that you do, the longer it's going to take, which is generally going to give you bottlenecks. Firewalls can be stateful or stateless. A stateless firewall is generally seen as an access control list, and this is working on static information. Packet filtering is done by matching a pre-approved condition. This is generally a lot faster because the information is static. A stateful firewall is actually considered based on full context. IP tables are considered stateful. With a stateful firewall for IP tables, once this traffic has been approved, it's added to the state table. If it wasn't approved, it can get blocked. And this is actually better at looking at unauthorized or forged information. At its most basic level, we have a firewall that can allow all or deny all. This is actually seen as the last rule in the chain, so that you have sort of an else condition. So after you've gone through all of the other firewall rules, if you get to the end of the chain and none of the rules have matched, then you might have a deny all or an allow all. And this will end up depending on the type of system that you're using. Deny all is safer, but it will take more work because if you have packets that are coming in and they don't match any of the previous rules in the chain and your decision is to deny them, you are likely going to have to go back and add rules to your chain. However, it is safer because you aren't allowing information into your network willy-nilly. Allow all is a little bit easier to manage. It generally has less maintenance because you're not adding rules to your chain at the same type of frequency. But if you have your last rule being allow all, that isn't as safe as a deny all. Now, this decision needs to be made based off of the system that you are working with and the company and the risks that they are willing to take. IP MAC addresses are the easiest thing for us to filter for because that's part of the packet that's sort of out there and easy to find. Data within the packet is going to be the slowest. You can also do things like filter by port. For example, a DNS server doesn't need to have ports for web or email because it's just DNS. Pings, while they are good for testing connections, that's one of the very first things that you should learn in networking. Can I ping my server? That can also allow for Nmap style attacks. And so you want to think about the benefits versus the potential problems. For a lot of systems, leaving ping open might not necessarily be an issue, but for some systems that are going to be attacked frequently, it might be more of a problem. An example of when we might end up wanting to look at the traffic coming through is distributed denial of service attacks. In the example of a DDoS attack, you might want to look at filtering a set of IP addresses or IP ranges. We could filter a range of addresses. I use the example of the CIS server. Because this server is based in the United States and it is for a community college for in-person, outside of pandemic, classes, we know that we're not going to have people from outside of the US legitimately trying to access the server because they aren't students. If they are a student, they are going to be taking classes on campus. So we can filter packets that are coming from outside of that if we want to. Good hackers can obviously get around that, but that's a way to sort of filter out the bulk of things coming in. The next thing that I would like you to do is find a buddy in class. If you do not already have somebody that you know in the class, go into the class's private Discord and find somebody that you can talk to. And what you and your buddy are going to do is you're going to work on what you think should happen in the case of a DDoS. Make a list of priorities and spec this out like you're creating a script. So if a DDoS is about to happen on your server, what do you think needs to happen? What is the first priority? We don't want to have, oh, a DDoS is coming, let me unplug my server. That's really not realistic. We want to think about how can we protect it without unplugging it. With Linux, firewalls can end up having multiple systems depending on the flavor of Linux that we're talking about. IPtables is the one that I've seen most commonly. However, you might also see NFtables, Firewall D, or UFW. Some are built in, some are third party. This is all going to be dependent on the flavor of Linux that you're using, so it's important that you know that so that you can familiarize yourself with that particular flavor. IPtables generally don't survive a reboot. However, you can create a script that will save all of your rules so that it can implement them again. And some versions of Linux do have ways to preserve the IPtable rules if you want to set that up. I also recommend looking at Julia Evans's comics. She has some really great comics with very nice short explanations. You can see I've included the one that she created for IPtables. If you would like to see her explanation, she did a beautiful job. The next activity that I'd like you all to do is find your IPtables in CentOS. I'd like you to list all of your rules, and then I'd like you to practice blocking an IP address and then deleting the rule blocking that range of addresses. Please take a moment to pause and go do this now. With a firewall, for an IP table, they're actually done in what's called a chain format. Rules matter. The order matters. So what's going to end up happening is as a packet comes in, it's going to start at the top of the chain and then run through each of the rules going down the chain. If a rule is used, the system will then do what matches that rule, and then we're all set. If none of the rules match, that's where we get into the allow all or deny all as the last rule in the chain. We have the option of accept, drop, or reject packets. If we accept a packet, it means that we are allowing the information to come into our server. If we drop the packet, we basically ignore it. It's the equivalent of putting your fingers in your ears and going la la la. If you do a reject, however, that will send an error back to the person that has sent you the information to let them know. You can actually do a script for base rules and modifying rules. So in the case of, for example, you're worried about somebody attacking your server, you could actually set up a script to deal with that. And that's going to be one of the things that you're going to start planning out for the lab. IPv6 is going to be similar to IPv4, but it does use separate files and separate commands. It's worth taking some time to familiarize what each of these are going to look like. These are some examples of firewall chain rules. We actually have different chains that might end up getting hit depending on when we are talking about in the system. We might have pre-routing, which is when packets are arriving. We might have an input, which is when packets are given to the local processes. Output, which is after they are produced by that process. If we have a router, we might have a forwarding chain. If we are sending packets back out of our system, that's going to be post routing. And each of those different chains are going to have different sets of rules. Example, you want to add in a basic rule. So you can see my example here is looking at how you would add in a rule for an IP table. Now, you can see in my example, I actually forgot to sudo this, so you can see where I did a sudo bang bang. If you see any of my live demos, you'll probably see that happen relatively frequently, and this is the sort of format that you're going to end up using. The next activity that I'd like you to do is get back with your buddy and write a script to show IP table rules, IPv6 table rules, add some headings and titles so it's clear what you're looking at. The second part of the activity is writing a script to shut down everybody on the system except you. This is your alternative to shutting down the whole system if a very serious hack has happened. Feel free to take a moment to pause me while you go set this up with your buddy. When we're talking about tables, there's actually different types of tables that you might end up seeing. Normally, we'll just end up seeing the filter table. This is the main table that people will use, and this is how we decide if we are allowing or denying packet access. Sometimes we might end up seeing things like the mangle table, where we would alter IP addresses of packets. If you are doing something like SE Linux, you might end up using the security table, but there are different tables that you might end up seeing and different places that you can add rules in. A DMZ, or demilitarized zone, is actually a safe place on our network where we're going to put what I lovingly refer to as the problem children. The problem children is the different services that have the potential to not only be attacked frequently, but generally also have the most vulnerabilities. One of the things that we can do with a firewall is actually redirect packets so that we don't have to worry about these particular services being on our main network. Let's say, for example, a website. We all know that websites, because they are generally available to the public, are going to be a large source of attack. There's also a lot of vulnerabilities that will happen in websites, both because of the amount of access that they might need. For example, if they are adding information to your database, that's a lot of access that they might need. And because this is publicly available, anything publicly available is by definition more vulnerable. So what we would actually do with a DMZ is we would say, if any traffic is coming in and looking for our website, I want to redirect these packets over to my web server. I do not want them to come into my main system. And so all of this forwarding will actually send those packets over to the DMZ to protect the rest of your more vulnerable systems that the public shouldn't be seeing. It is very normal for the public to see your website. It would be significantly less normal or good for the public to see, for example, your internal database of customers. The most common things that you'll see in a DMZ is going to be a web server, your email server, a VoIP server, or if you have a FTP server. You might also end up seeing dual firewalls. So you can use a single firewall and from the internet have that firewall either allow packets to come into your local network or redirect them to a DMZ. You can also actually have multiple firewalls. This is very common in industry where you would have an external firewall that might forward to the DMZ, and then you would have an internal firewall that would then forward to your local area network. Second firewall is generally backend and it only allows traffic to DMZ from internal, and it's one of the ways we can give an extra layer of protection. A lot of times in industry, what you'll actually see is the different firewalls will actually be from different vendors. So if they have a vulnerability, we don't just have the same. If you think of a firewall as a literal brick wall, it doesn't have the same brick missing for both or all of the firewalls that you are using. The activity for the week is you're going to be writing some scripts or statements to modify firewall rules. I have written this in sort of vague language because you need to make some decisions about what you think is the most reasonable for your servers. For example, if you are dealing with a web server, for you and your servers, what makes the most sense? Do you need to worry about ports, forwarding ports? What else might you need to worry about? Do you need to protect things? And I have a list of things that you're going to need to deal with, and then you're going to use Wireshark to show that your statements or scripts are working properly. You're also going to want to start speccing out what you could do to prevent a DDoS attack using your IP tables. Is there a script that you could write for this? If you have any questions, please let me know.